Hello, this is Mrs. Wong here. Okay, for this video, we will be using your Chapter 1 Worksheet 2, and then we will be looking at perfect cubes. Okay, so in the earlier lessons, we have actually done perfect squares, fill in the tables, okay, and learn how we can use square roots, how we can find square roots of certain numbers using prime factorization. Okay, so now we'll be looking at perfect cubes. Okay, so for this table, it's very similar to the table on page 1 on perfect squares. Okay, so I'll need you to fill in the table as well. When I have 1 and I cube the number 1, I will have actually 1 times 1 times 1, and that is 1. Okay, 2 cube is 2 times 2 times 2, which is 8. 3 cube is 3 times 3 times 3, which is 27. Okay, so I'll give you all some time to fill in, pause the video, fill in the numbers, find the values, okay, first. Okay, so you should fill in the table. Okay, I'll leave you to fill in the numbers here. Okay, please don't use this epilepsis like me. You should fill in all the boxes and work out the perfect cubes. Okay, so label. Okay, so all the numbers here are your perfect cubes. Okay, remember that the perfect squares and perfect cubes, okay, they are the numbers here after you square or you cube the numbers. Okay, so the perfect cubes between 1 and 1,000 are actually all this. Okay, then we will go on to the next part. Okay, it's also similar to finding square roots using prime factorization, but now we are going to find cube roots instead. Okay, but the process is very similar. The steps are written here. So if I want to evaluate the cube root of 343, then I will need to first find the prime factorization of 343. Then I take the cube root of this prime factorization. So can you all find the prime factorization of 343 first before you continue the video? Okay, so 343 is actually 7 cube. If I want to find the cube root of 343, it's the same as finding the cube root of 7 cube. Okay, so from here, okay, if let's say I have the square root of 7 to the power of something, okay, then what the square root does is it will take the power of n divided by 2. Okay, now for cube root, okay, if I want to find the cube root of 7 to the power of a number, it will actually be 7 to the power of n divided by 3. Okay, now for the square root, we do not write the square here, okay, because for square roots is taken as known, okay, that is a 2. Okay, but for if I want to take the cube root, okay, or if I want to find the fourth root of something, or if I want to find the fifth root, okay, of value, okay, so we will have to write the 3, 4, 5 and so on. But for the square root, okay, this thing, okay, these two I do not have to write it. Okay, now let's continue. Okay, so this is actually 7 to the power of, now I want to take the original power 3 and divide by 3. Okay, the divide by 3 is a result of the cube root. Okay, it's a result of the cube root, which will actually give me 7 to the power of 1. Okay, and then it's actually 7. Okay, so those of you who are very clear, actually you don't have to write this step. Usually we do not write this step. Okay, but we have to know that we are taking the power of 3 divided by 3. Okay, now if the power here is not 3, let's say it's 6, then it will become 6 divided by 3, then it's 7 square. Then you have to evaluate 7 square. Okay, so it depends on the question. Okay, then let us now try page 12, practice now 6, question 2. Okay, so your practice now 6. Okay, question 2 is this. Okay, given that the prime factorization of 9261 is this, 3 cube times 7 cube. They want you to find the cube root of 9261 without using a calculator. Okay, so I'll write that in. So cube root of 9261 is the cube root of 3 cube times 7 cube. Okay, now very similar to the square root, okay, the special property of square roots, I can actually now break this up into the cube root of 3 cube multiplied by the cube root of 7 cube. Okay, so the special property, okay, if it's a cube root of two numbers multiplied together, I can break it up into the cube root of each of the two numbers, and then I multiply them. It will be the same. Okay, then I will get 3 times 7. Since for both powers, I actually have to divide by 3. And that will give me 21. Okay. Now I want you to take some time to try the challenge questions. Okay, this one, in this case, we do have 1 actually. So given that the cube root of 512 is 8, we want to evaluate the cube root of 4096. So I'm going to try and link 521 with 4096. Okay, so if you were to try your calculations, okay, so we actually get 4096 is actually 512 multiplied by 8. Okay, so I take 4096, the bigger number, and I divide by 512, and I actually get 8. Okay, so when I want to take the cube root of 4096, is actually the cube root of this whole thing, 512 times 8. Okay, then I use a special property. Okay, I will break into cube root of 512 and the cube root of 8. Okay, so I know that the cube root of 512 is actually 8. Okay, now this one, I'm going to change 8. Okay, 8 is actually a perfect cube. Okay, why? Because when I try, I can actually convert this into 2 to the power 3. Okay, so I'm going to change 8 to 2 to the power 3. Okay, why I'm so happy that it's a perfect cube? Because when I take the cube root of a perfect cube, I get a whole number. Okay, so here, if I were to continue here, it would be 8 times 2. So I get the cube root of 4096 is actually 16. Okay, now the next one, these questions are also slightly more challenging because it tests concepts of perfect squares, perfect cubes, and prime factorization. Okay, so we'll be looking at textbook page 13, practice now 7. Okay, so practice now 7 is here. The questions might look a bit foreign now, but don't worry, we will try them together and then we will see how we can understand them. Okay, now you can actually read the work example 7 on the previous page. Okay, so if you go to the previous page, work example 7, okay, they do have an example that can try and help you with the questions in practice now 7. Okay, so I need you to pause the video, take some time to read what is in practice now 7, try and make sense of it. Work example 7, work example 7, then we try practice now 7. Okay, so you should have read through the practice now 7 and read work example 7 as well to try and help you. So now we're going to try and do question number 1. Okay, so part 1 wants us to use prime factors to explain why 15 times 135 is a perfect square. Okay, so for this question, there are actually two things. First, 15 times 135, and I need to use prime factors to explain why this multiplication of these two numbers is a perfect square. So they're testing quite a few concepts. They're testing on prime factors and perfect square. Okay, so for a start, let's write 15 in its prime as a multiplication of its prime numbers. Okay, so prime factorization for 15 and prime factorization of 135. Okay, so the first thing we will do is that. Okay, so we write out the prime factorization of these two numbers. Then now we are going to put them together. 15 times 135. Okay, so I write it in. Now I'm going to combine, okay, the 3 and times 3 cube. So 3 cube is 3 times 3 times 3. If I times another 3, I will actually have 4 of them. So it's 3 to the power 4. Same for 5 times 5. Okay, I will combine them together to get 5 square. Okay, now, so they want us to now explain why this, okay, which is equals to this, why is this a perfect square? Okay, why is this a perfect square? So we have to go back and think about our definition of perfect squares. How do we know that a number is a perfect square? Okay, it's a perfect square if, okay, if we take the square root of that number and we can actually get the whole number. Okay, then we get it as a perfect square. Or if we can write it as something to the power 2. Okay, then we know that that number is a perfect square. Okay, so for this, there's a few ways for you to explain. Okay, I can actually write this as 3 square times 5 and square it. Okay, so now what I'm doing is I'm extracting a square out. I'm extracting this square out from 5 square and 3 power 4. So the remainder is 2 of it and 1 of it. Okay, to show that this is a perfect square. Okay, or I'm going to write in a different color. Or if I want to take the square root of 15 times 135, okay, it will be the square root of 3 to the power 4 times 5 square. Then you take the square root of this, square root of this, okay, and then it's 3 squared times 5. Okay, so either you use this and say that since it can be written as n square, where n is a whole number, then this is a perfect square. Or you can use the second way of explaining it, okay, and say that since the square root of the number, okay, is a whole number, okay, then the one without the square root, 15 times 135, is a perfect square. Okay, let's go on to part 2. Okay, for part 2, they say that k is a non-zero whole number given that 15 times 135 times k is a perfect cube. They want us to write down the smallest value of k. Okay, so k is a non-zero whole number. K cannot be 0. Okay, and 15 times 135 times k will give me a perfect cube. They want us to write down the smallest value of k. So now I write it out. Okay, so 15 times 135 from part 1, we know it's 3 to the power 4 times 5 square. So I just write out the equivalence. Okay, then now they want this, okay, to be a perfect cube. Okay, meaning they want this, okay, these two are perfect cubes. Okay, so how do I make it a perfect cube? Then you have to think about the definition of a perfect cube. Okay, it's similar to the perfect square. Okay, but instead of having to write it as n square, okay, it must be n cube. Okay, so now the powers of 3 and 5, okay, the power here has to be a multiple of 3 in order for it to be a perfect cube. Okay, whereas for a perfect square, I want my powers, okay, to be multiples of 2. Okay, so how do I make 3 to the power of 4 become a 3 to the power of a number that is a multiple of 3? Okay, so I'm multiplying, so I cannot change it to 3 to the power of 3 because it's already 3 to the power of 4. So the only way is for me to have k is equals to 3 square, so that when I take 3 to the power of 4 multiplied by 3 square, it will be 3 to the power of 6. Okay, then I want to make 5 square become 5 to the power cube. So the k must have a 5. Then my k has to be 45.